have our speakers come from a research institute, VTT, Technical Research Center of Finland, also from PrintoCent, as I've told you, and then from 3 companies, from startups to a large corporation like Nokia. At the end, there will be a Q&A live session. And so before we jump to the presentations, I'd like to remind you of just a few housekeeping topics. One is that this webinar will be recorded and will be available on demand. And the other important thing is we will have a Q&A session live at the end of the webinar. So we have enabled the Q&A feature in this Zoom session. You can get to the Q&A feature at the bottom of your screen. So if you have any questions, please type them in. You actually have to type them in so that all the speakers can see what you are asking. And then what we will do is answer some questions in writing. And then those that have not been answered in writing by our speakers, we will take those to the Q&A live at the end. Also, if you have any questions after the webinar, or if any answers were left unanswered, you can still send those and get in touch with any of the speakers through a survey that we will be sending out after the webinar closes. So in that survey, you can ask more questions and also give us feedback about the webinar and any suggestions, any comments you may have. And finally, I really would like to also highlight that this is just the first session of this webinar series. There will be more sessions that I will introduce after the talks. But from the start, I'd like to let you know and ask that you also share this webinar series with your social networks. So let's finally kick things off by welcoming today's first speaker, Antti Kemppainen from VTT Technical Research Center of Finland. VTT, some of you already might know, is a pioneering institute in this field of printed intelligence. And Antti is a professional in the field for almost 20 years. He has a lot of experience with printed and hybrid electronics and its application. He has been involved with dozens, if not hundreds of projects with technology companies from this space and also from brand owner end users that are interested in printed technology, printed electronics technologies to integrate in their own products. So Antti will give us an introduction to printed intelligence, and we'll focus on a few highlights to illustrate the capabilities of this great set of technologies. Antti, the floor is yours. Thank you and welcome again.
Thank you very much, Ines.
I will stop sharing my screen and you can share yours.
Okay, just a second. Thank you, Ines, for your kind words.
I've known Antti for, what, 10 years almost now, Antti?
Yes, that's right. Do you see my slides now?
Not yet.
Okay, I always need to press the extra. Sorry. It should. Okay. Now, sorry about that. I have been practicing, but it doesn't seem to be so easy. Okay, now better.
Yes.
Yes, as Ines said, it's 20 years when I did my first printed intelligence project here at VT. So I'm obsessed to start with the old slide and tell about the foundation and basics. So what we started is a way to use additive manufacturing printing to make high throughput, large area, high speed, even in roll-to-roll processing of new functional surfaces and electronics. Definitely we had a twist from a multidisciplinary approach, having biomaterials, biotechnology inside already from the start. The first years really process development and lots of components, elementary components are developed early on, quite a long time ago. The big step definitely was the approach of printed hybrid systems that we decided that we will use the advances of the conventional electronics, silicon-based electronics, microelectronics that we have, microprocessors, radios, to form cost-efficient still, but effective interface to the infrastructure, like mobile phones, computers, later cloud computing. The third step of printed electronics processing is definitely the post-processing. Even though we first print the film, put some components on, then we need to still convert this to smart labels, smart packaging, smart plastics, or whatsoever. And during these years, maybe the driving reasons why the use of printed electronics have been slightly changing, because it has been not so easy to just enter to the technology fields in just cost reduction of existing products. But all the success stories that we see in the printed intelligence are based on form factor, novel integration, and freedom of design combined with these originating ideas of production, highly automated production. And definitely one of the biggest benefits of printed intelligence is that we have very wide materials portfolio for the substrate, for the processing, for the active materials that is really enabled many applications that are not easy to make with the conventional electronics. Then to the highlights that actually I promised, that what we have seen, that the rising stars of printed electronics technologies, and definitely one lately has been last 10 years the structural electronics. That means that we use printed intelligence as a vehicle to integrate functionality into different surfaces than conventional electronics. Like in this case, our member company Tactotec has a really leading company in developing plastic integrated electronics. So here the concept is that you print, you assemble components, you form the film, and then you finalize the product by integrating that using injection molding into plastics. So what this enables is really three-form functional plastics for user interfaces for different components, and that has been really get a lot of interest from the automotive and consumer electronics. Another integration concept that has been, to be honest, a little bit surprising after starting days is that we really can utilize printed flexible electronics as a form to integrate stuff into glass. Member company FlexBrite has been here showing that they can make a windscreen display for a bus in a curved surface inside the glass laminate. It's not laminated to glass, but it's really inside. The second application, certainly interesting in these times, is an antibacterial lighting for the shop environments and different environments. So now the benefit is that inside the glass it's really kind of a hygienic and robust and washable surface, and it can perform the other function of being antibacterial. The second highlight I want to, and we will be hearing more on these both topics during the PrintoCent webinar series, next sessions. But the diagnostic is definitely one of the interest applications because of the fact, again, we having different materials that can be used. We can combine biomaterials together with the functional structures, electronics, and microstructures, for example. And there is definitely a first generation of products out. For example, these kind of indicators, visual indicators that show by color change the measurement data, disposable sensor products. And definitely in diagnostics field, the digitalization is the next step. And there's a clever, really nice work by iStock here that they have developed a rapid diagnostic test that is then read out with the mobile phone. And this enables the full use of big data and cloud computing in this application, and enables to use these tests in really environments where there is not existing infrastructure for healthcare services. And the one topic that we see a very interesting and bright future is that through the stretchability that can be used in printed intelligence, we can make nicely wearable. We can integrate the sensor platforms, radios, Bluetooth on the stretchable surface. So using this, we can integrate to clothing, to shoe sole, or to skin. And this will in future enable the continuous monitoring of let's say, your condition, health and well-being. And definitely this is a topic we will hear in the next seminar more. The third highlight I want to raise is some topic that has been really found out a big opportunity during the last couple of years, that we have tools in printed intelligence to enter to the sustainable electronics. We have just launched this project called Ecotronics, that we try to look at how do we utilize these biodegradable materials that can be used, how to improve the recyclability, and how to reduce the use of materials. And I really recommend that you could take a look on a blog by our Ecotronics project manager, Liisa Hakola's blog. But all these demos and applications, they are not so valuable if you don't have way to manufacture, and just not trying to explain all things, but I will show a short video from our pilot fab that what things can be done to try to convince you that there's way to go forward. So I shut up for the time of this video. But the pilot factory itself is not definitely enough, but I'm very happy and proud to see the development in PrintoCent industry cluster during the last years, and all the investment that has happened in the industry cluster members. And that's why I would like to conclude and hope that you have brave ideas and can go forward with the printed intelligence. Thank you.
Thank you, Antti. Thank you for your inspiring talk. I'm sure that it has sparked a lot of ideas already in our audience today. Let me share my screen. Can you stop sharing your screen?
Yes,
yes,
I did it.
Thank you. Okay, so before we move on, I actually would just like to mention that this webinar, the duration of the webinar will be about 1 hour and 15, 1 hour and a half. That was one of the questions that showed up in our Q&A, and I forgot to mention that at the beginning. But now that we have seen some of the possibilities that can come up from printed electronics and printed intelligence technologies, we proceed to a presentation from Jukka Jätinen from PrintoCent. And Jukka really is going to explain more about this network and how it can really help companies drive growth in the commercial adoption of these new technologies. Jukka has a very diverse background, having worked more than 20 years in both large corporations and SMEs, in positions from R&D to business director, and he currently is the co-creation manager for PrintoCent. The floor is yours, Jukka.
Thank you, Ines, and hello, everybody. So, like Ines introduced, I'm working as a co-creation manager at PrintoCent, and I'm telling you a story about PrintoCent, what we are and what we do. I hope you can see my slides.
We can see slides, yes.
PrintoCent, what we are, what we do. We are the printed intelligent hub for innovation and industrialization. We've been founded 11 years ago by VTT, Technical Research Center of Finland, University of Oulu, University of Applied Sciences, Oulu, and City of Oulu. Currently, we have more than 100 professionals working in research, in universities, and in VTT for the printed intelligence. What we do, we offer research, prototyping, and scaling up services for our members and for our customers. We exist for the industry, and we are aiming to commercialize the results of the research projects what we are doing together. We also accelerate joint development of activities between our members, creating value chains, creating new products, creating new businesses. PrintoCent is led by VTT and other founding members. Some facts about the VTT and the universities of Oulu and Oulu University of Applied Sciences. VTT has more than 2,000 employees. Our turnover is 270 million euros, and our research ranking in Horizon 2020 goals is 4. Universities in Oulu, they have together 22,000 students and 3,500 employees. We are working under the guidance of PrintoCent board, which is consisting of founding members and industry representatives. Anyhow, we have founded officially 2009, but we have a much longer history, like we heard from Mr. Antti Kemppainen's presentation. The first project regarding the printed intelligence was done in late 90s. It was funded by Business Finland. We raised interest among the industry. We made first investments for the machinery in the early 2000s. And after that, we have been developing towards today. What we have achieved? We have created 30 startups. We have collected 50 million euro investments to the industry. We have more than 500 employees in the SMEs and in research in Oulu region. And of course, we have done a lot of research. We also have goals for next 5 years. We are going to establish a strong printed intelligence development and manufacturing hub to Oulu, which has a satellite partners in Europe. We are also aiming to collect 100 million euro investments to the companies during next 5 years and continue investments to research and education. How we are doing that? In current 3-year period, we have some themes and key actions and goals related to those themes, how we are going to achieve these goals. We are networking towards the ecosystems. We are doing marketing, scouting, resourcing of different topics. We are creating innovations, new products to gather our members and our customers. And we are offering, of course, our services, doing the industrialization towards the open fab and the 100 million in investment for the industry. Like mentioned several times, and also Ines mentioned during her speech, we have an industry cluster. We have 40 members at the moment. They are from startups to large-scale enterprises. Half of the members are from Oulu region. 1/4 is from other part of Finland, and 1/4 are from abroad. Like you see, we have many international large-scale companies also in our cluster. But who are the cluster members? You can find that information, our membership catalog. It's available in our web page, PrintoCent.net. There is a description about our members, their companies, about their competencies, and of course their contact information. So please have a look and study more about our members. Then, like we see already a nice video in Antti's presentation, we have a pilot factory with which we are serving our customers and members. They are located in our premises here at VTT or in the universities of Oulu. Doesn't matter which area of printed intelligence or electronics we are talking about. We can serve our customers and our members in the area of structural electronics, health and well-being, or construction glazing integrated functionality. We have also written handbook. Actually, it's written by our mainly by our industry members, companies like Tactotech, FlexBrite, Synolis. There's a lot of information. This is already a 2nd edition. So it's 270 pages of information regarding the materials, processes, manufacturing and integration methods, process and quality control, design guidelines, design examples, demonstrators, components and devices, starting from the passive components up to microfluidic devices. This is available in PrintoCent webpage. It's available for free of charge. So please download your own copy and enjoy about our handbook. We are also organizing education in the field of printed intelligence. There's a degree programs and tailored courses available. Those courses are available, are offered by the University of Oulu and the University of Applied Sciences of Oulu. There is a Bachelor of Science and Master of Science and doctoral studies courses available. And special courses can be arranged as well. Then about the events and the activities, what we offer. I think maybe most two famous ones are the Princess seminars and the InnoFest happenings. Like Ines already told, during these days, during these times, we should be sitting next to the sea in the Nalikari beach and having an InnoFest session there, boosting the new innovations. Unfortunately, we are here in the web, but we are happy to offer this seminar and seminar series to you instead of InnoFest at these days. The Princess seminar is the industry seminar. We already have organized 6 of them. Last seminar was organized last January. There was 280 participants from 24 different countries. Representatives came from 95 different companies, and we had an industry 60 industry speakers there. So it's really an industry seminar about the printed intelligence. I hope you have enjoyed these if you have joined, and if you have not joined, so you have to come next time. The Princess seminars are organized every second year. The InnoFest, there we are boosting your ideas. Last spring, we had 140 participants in the seminar in 20 different teams, boosting 20 different ideas for 2 days period. We also arrange specific seminars and printer sample events of different topics. We organize industry cluster meetings among our members. We also offer possibilities to pitching to the investors, to our members and the partners. And that's our main offering regarding the events and the activities. For these words, I will thank you about the interest of the PrintoCent, and I hope you will have a look about our handbook to become, and also our catalog to become familiar with our members. And if you have questions, we have a special Q&A session after the seminar. So thank you.
Thank you, Jukka. This was a great perspective on the main achievements of PrintoCent so far, but also great to see the ambitious targets for the future. And I'd say that I really encourage everyone that is not familiar with this space to go check out the handbook. It is an incredible resource to start with. And you'll get to know many companies, many technologies through that handbook alone. And it is free, as Jukka was just mentioning. So great resource there. So let me share my screen again. We are going to move on with the webinar. So we've had already introductions to printed intelligence from Antti, and we've also got to know PrintoCent much better with the last presentation. We are now going to move on with company presentations. So we're going from the institutes and the networks to the cases of the companies. And these companies will be Movesole, Nokia and Ynvisible. And really they're going to show us what they are doing with their technologies at the moment, and really what their intentions are in the future with these set of printed electronics technologies. So first we welcome Eero Kaikkonen from Movesole. Eero was actually a pioneer in developing the first generations of mobile phones, and has since been an entrepreneur and a coach to dozens of startups. So huge experience here with new technologies throughout his career. He has founded Movesole and has been its CEO since 2014, and also has been actively involved with PrintoCent for the last 10 years. So please tell us more about your company, about your technology and your products. Eero, welcome again.
Thank you. Okay. Before I do anything else, I promise something. Can you see me now?
Yes, we can see you. You just have to.
Yep, I promised to show you something. So hopefully the corona goes away and next year and you all can have this beautiful t-shirt. And I really recommend this event. I have been co-hosting it for the last 6 years. And it's, to me, it's more or less like the highlight of the year. It's really a great event. So please, I hope to see you all there. Now, if I can figure out my slides. Hopefully, can you see now my slides?
Not yet.
Okay.
Can you try again?
What about that? Same thing now, to be extra artist, and this was working well.
Murphy's Law. Always there.
Yeah. And still you don't see me, okay?
We see you, but we don't see your slides, not yet.
Running out of the tricks here.
So you're using your share screen
Yep.
option.
Let me try again.
It's coming up.
Okay, good.
You got it. Yes.
Excellent. Sorry about this. Okay, so hey, I'm going to speak you shortly about Movesole, but before going there, just kind of tell you a little bit about what we see as a bigger trend in healthcare. So Movesole is focusing on healthcare and welfare. And I think there's two big trends where printed intelligence is going to also play a role in healthcare. And those two things is that going forward, now we focusing on Corona, so things look a little different in the last 3 months, but if you're looking for years to come, we should focus on two things on healthcare. The one is that we should more and more focus on monitoring the health instead of the curing the sickness, and that's the trend. So we should kind of try to build the healthcare so that we can prevent things happen instead of just reacting when it happens. Then there will be also things like Corona, which we can't stop before they happen, but in the bigger picture. And the other thing is in healthcare that we, instead of building the walls and building the hospitals and clinics, we should take the healthcare where the people are. So instead of people going to hospitals, the healthcare system should go closer to people in this new global world. And that's what I'm using here as a motion and walking as an example. So I'm going to walk you through what we do and a few things, like speak about what gait analysis is, so how we analyze how we walk, and how to measure data from there and why we're doing that, and then about our insoles and few solutions and technologies we're using there and why we decided to do the way we do it. But let's start with the human gait. So walking, we came down, it depends on the source, but somewhere between 5 and 2 million years ago, we came down from the trees and started to walk with our 2 feet. And one would think that that's something which we know very much about. And during the last 5 years, I've been really surprised to learn that, well, we don't know so much about it. We know how to walk, most of us at least, but how it affects and how to treat people with different kind of pains has been really under a strong research during the last 30, 40 years. And it's only like last 20 years that we have been realizing, or the physiotherapists and doctors have been realizing that that how the the human body is working as a total unit. So if you have a pain in the knee, it might be the reason for that might be somewhere else, or if there's a pain in your back, it might be the way you walk. So understanding how we walk and understanding how to measure that is very important. So there's a need how to measure. And if you think of how we work today, the physiotherapists only basically they use their eye. So if there's an experienced physiotherapist, they see a lot only by watching you. So that's what happens today. If you go to physiotherapist, the first thing they do, they make you walk and they watch you. And don't get me wrong, if they are good, they are very good. They see a lot about it, but there's two things. One, I've been meeting like 300-400 physiotherapists during the last couple of years, and the guys who are very experienced say that you see only that much by your eye. At some point, it's like in making an agreement with the lawyers, that they will see the details. The small things that happens inside of your shoe under your feet is the ones which you don't see, but which will affect very much on your walking. So there's a need for a more data to see how it, and the second thing is that if you go to one physiotherapist and you go to next time you see somebody else, they don't know what happened before if there's no measured data. If you today need to have some measurements of your walking, there are solutions, but they're mainly focused in the big hospitals, like the university hospitals here in Finland. And there are laboratories where you can get the gait analysis. And then there are some clinics who are focusing on that one. But that means that you go to the certain place, you maybe take a few steps, but it's not the natural environment of how you walk. The gait analysis, or the analyzing how you walk, is very important. There's a huge amount of the different use cases, and also I leave it the numbers here, but there's a huge amount of people who could be helped if we could help them to analyze, or they could be analyzed how to walk and maybe improve something out there. So our kind of starting point is that we started to build a product that helps to go and measure the people they're walking in the place where they are in their everyday life. And we started with the lower limb injuries, but pretty soon we realized that there are so many other places where we could use our tools. Like an example, so it's a diabetic feet ulcers where we can help them. It's of course sport and exercises, occupational health. A lot of people suffer from back pain coming from how they work and how they walk on the work or whatever. And then active aging. So walking is a very good way to analyze what is your condition and how good you shape, and if you take some exercises, does it really affect on your condition? So the use cases are huge. And going to what we started to do, so we took those tools which were in the hospital. So there's a pressure match, there's a force plates, and we integrate into one insole. So it does both. So it measures how much force you're using when you're walking and how that forces are split under your feet. And that's the two elements that the physiotherapists need from your walking when they try to analyze how you walk and what can be done to help you. Then going to more what we do when you build the products, you have to understand to whom you're doing. That's why we have split our product portfolio to two solutions. One we call Movesole Step Lab. That is for the physiotherapists, and for reason being that that product is for analyzing on average how you walk. So if you walk like they say, physiotherapists say when you are in a rehabilitation, I'm not interested about the next step you take, but I'm interested about how you walk the next 10 kilometers. So they need average results. We built them product that analyzes and averages out. But then we have a research customers who want to see every single step, how it goes. So we kind of separated those two. We have like a healthcare product, and then we have a research product. In simplified, it's an insole, which measures the forces and how they split. It sends the data over the Bluetooth, the application, and it goes to the cloud. And this picture I just want to show is that for the healthcare, the thing we understood soon was that we don't waste their time of using our tools or trying to figure out the results. They need to see something in a split of seconds rather than minutes. So we have built like something on the screen that they can check out in a few seconds and see what happens there, and then continue to work with the patient, which is the key element for them, not to use our tools, but to work with the patients and help them. So we wanted to make as simple and as fast and as as easy to use as possible. So I will speak more about that. This is only to show that we need to be sure when we are in the healthcare and when we are in the welfare that the results we do we show are accurate. So that's why we spend a lot of time, testing our tools against those hospital level tools and seeing that the results are correct. So of course, the results has to be on the cloud. So that's what we do. You can send the results on your data on the cloud. You can even follow up. So if the patient is using them at home, you as a healthcare professional can see from the cloud what's going on there, maybe call them. So that is how you do the monitoring. So you have the results, somebody, patient is somewhere and you can see the results somewhere else. And this is on the box what we, so this is the product we have. So we have built insoles that measure how you walk, the force under you and the split of the force under your feet. This is like a healthcare professional tool, which is kind of 6 different sizes. So basically it's so that whatever is the size of the feet for your patient, you have an insole for them. Now, the original logic was that why printed electronics and why hybrid? And I was thinking for this, and the printed electronics and building this kind of insole is no question about it. It's the only way of doing it because we need to put some wiring in the insole, which has to be as thin as possible. And there is really no other way. So you can use like a printing of the wires, you can use the etching of the wires, but anyway, you need to do somewhere the wires. So we need to do something on printing. Then going to the hybrid. So the original idea for us was that we put all the electronics, the microprocessors, the Bluetooth transmitter and everything inside of, so we do really a hybrid product. But then comes the, you have to understand what you're doing. So we learn from our customers that the insole is, because it's a measurement device, less it affects on the walking. So if it would be too thick, and you put it inside the shoe, you start walking differently. And then we are not measuring, but we are changing the way to walk and then measuring. And so we need to take a lot of the technology, the electronics outside of that. That's why we have this cable, and then that's why we have this separate box which is on your ankle, where the the processor is and where the Bluetooth is. On the other hand, then there was a question about the robustness. So most of the sensors today, what you see in those insoles, it's like a capacitive or resistive sensor, which means it's like a ring of the wires, on circles, and that is measuring what you do. And the problem with those is that it's quite a hostile environment when you put the insole in your feet and you start walking it. And for us, we figure out that we find out a different type of the sensor, which is called like electromagnetic films. And the good news on that one, it also measures and it changes the currency based on how much pressure there is, but it's basically unbreakable. So we call it also hybrid. So the sensors are not like printed, but it's even though it's like a plastic paper, it's a component on that one. So we combine 2 different technologies. And that was done because we want to find the best possible solution there. But when you build a product for the healthcare, so there's a lot of other things we were needing. We need to build a product that lasts long enough. And especially we need to build a product that the measurements are reliable. But then again, when we visit with our customers and what we see, we need to think about the usability from the 2 different point of view. The one is the healthcare professional, the ease of use for them. So when one patient comes and goes, the next comes in. Using the tools shouldn't take a time from treating the patient. So we aim to build a product that it takes 30 seconds to start using it with the patient, 30 seconds to take it away, and next patient can come in. So we don't waste the time between the patient and the healthcare professional. The tools are easy to use and easy to implement. But at the same time, we need to think about the patient themselves. So convenient to wear for them is that they don't notice, because if they notice there's something inside of their shoes, it affects how they walk. So the best thank you from our patients has been, I forgot that I am wearing this insole. So building a product, like for us, the first prototype that measured something took us like 3 weeks. To build a product that is good enough for the healthcare professionals, is robust and easy to use and easy to wear, took us 3 years. And that tells the challenges. There's a technologies that enable things, but for us, the key learning was that we have to learn where it used and how it used, and after that we were able to start building a product that is good for the market. So with that, I end my presentation, and thank you for your interest.
Thank you, Eero. That was amazing, and some of those messages are really important in terms of product development. is all about making the product user-friendly and really respond to the needs of the client. There's also a huge amount of effort that goes into that and multiple perspectives that one has to take into consideration when developing a product. And of course, it took, as you said, it took you 3 years. Also great to see how really printed electronics can be used where traditional electronics cannot. And so how it enables new form factors, which is really what you have shown us as well. So let's carry on now with the next speaker. We have Juha Annola from Nokia. So we go from a startup to a large company that we all know. And Juha will be telling us about 5G and the benefits of 5G in really enabling new business opportunities. Juha has held several positions in the past 20 years, connected to mobile networks, printed intelligence, and its applications also in health and medical solutions. So we welcome Juha now. The floor is yours.
Hello and welcome from my behalf. So I'm located here in Oulu, Finland, and working for Nokia. So my topic is about 5G and then about smart objects and then about printed intelligence. Eero had his foot firmly on ground, so I will go a bit higher and I will look 20 years back to the history, and then I have a look 20 years towards the future. So I will scratch a surface about these topics. The picture you can see on the screen is actually from our Nokia Oulu campus. We have tower there, and there is Nokia drone flying around measuring 5G. It's kind of smart moving object as its own, so we are already using those in real work every day. Just one word about Nokia. So we have 100,000 employees around the world, and we ensure you keep connected wherever you go. in 1 minute. So it is the technology to connect the world. It's 5th generation continuation on wireless communication, which has been going for decades and will continue to go. In a nutshell, it offers more with less. I will not go deeper to the technology itself. It's a long story. I will take one viewpoint to this a bit closer. So let's spend a minute and figure out that what has happened to antennas over the decades. Oldest of you remember the good old times when the handsets were huge and they had really long antenna. If you pick from your pocket your handset, it has a lot of antennas, but you can't see them, thanks to printed electronics. Same is happening on network infrastructure side as well. On previous technologies, it was typically just few quite big antennas over there. 5G antennas delivering massing MIMO and beamforming have even hundreds of antennas integrated in. So this trend around antennas continues still. And printed electronics will have its place there. What is connecting? 20 years ago, we were connecting people. Advanced people had handset on those days. Since then, pretty much all people are connected, and the development curve has been kind of S-curve type, because we are just few billion people around. With objects today, we are at the same spot we were with people 20 years back. Most advanced objects are connected today. Some cars, drones, and so on, but there are still quite many not connected. And if we look 20 years towards the future, this getting objects connected is not S-curve-like, but it will be exponential growth, because there are a bunch more objects than people on the planet. And as the technology gets improving, it's easier and easier to get more and more objects connected, even smaller than this Eero's food stuff. What is smart? We people tend to think we are quite smart. We are able to harvest energy, store it here and there, receive and store inputs, even process, and some people think they have some logic in their behavior. And we are able to even send some outputs and even move. What is smart object? It's actually the same. And once objects are really having different form factors and sizes, not all objects are kind of engineered like cubics with long antennas. Objects tend to have different form factors. It's easy to build cubic-like objects with antenna, but customers do not typically like those. It means we need printed intelligence around. Few practical examples. So this is Nokia drone in Japan warning about tsunami. It has all these smart features we just discussed. It has also antenna stick here, like handsets we are having on the old good days. But once drones will do more and more complex things, they need to have more and more bandwidth to keep connected. All objects need to take their surfaces and bodies in use to create this connectivity, process the logic, and send and receive inputs and outputs. So we need to utilize this surface more to get, for example, antenna gains in place so that we can send and receive more energy efficiently important information. Drones are a huge area on its own. We are co-working with many partners there. This picture is from our Nokia Oulu factory, where we are manufacturing 5G equipment to be delivered around the world. This robot is autonomously delivering components around the factory. It has all these smart features, including antennas you can't see at the moment there, but they still are there. Few years back we did with VTT colleagues kind of experiment that how small autonomous sensor you can do. And already those days it was evident that you can do quite a small solar powered autonomous sensor. Today you could do surely even smaller. So those sensors and objects are going smaller and smaller. It will put some challenge also for system on chip and architecture, how objects are created. If there's somebody working with system on chips or architects around objects, traditionally for decades, industry has been integrating as much intelligence into as tiny chipsets as possible. But as we go towards smaller and more stretchable and more robust and so on objects, we need to spread the intelligence around in really tiny silicons compared to the traditional one. So to conclude, once we look 20 years towards the future, we need these new technologies to connect the world. We need telecom engineers to improve this way to deliver data over the air, for example, with 5G. But then we need also, for example, printed electronics. Nobody wants to have 20 centimeter long antenna attached to glasses. So antenna technology is one of the areas where printed electronics can help on this path. But mostly we need people to make this exponential growth curve happening. We need people with different skills. We need these telecom engineers, but we need chemistry folks to develop new materials, new battery technologies. We need manufacturing experts to make new ways to manufacture these types of objects. So in the end of the day, manufacturing objects today is quite a big business. But now we need to build this whole value chain from the very beginning, from materials and so on, up to the delivery, to make this kind of new way to do objects in an efficient way. And PrintoCent is actually quite good forum, like we have heard, to make this value chain from end to end. In the end of the day, we always need to ask, why on earth? This is a bit philosophical question, but I point two corners to this. One is that during this year, everybody around the world has noticed that connectivity is actually quite crucial. Another angle to this is the environment. We need to do more with less. And once we have smart objects and nice connectivity, we can do more with less. There is a lot to be still improved in industries, agriculture, transportation, healthcare. So let's do it together. Thanks.
Thank you. Thank you, Juha, for a very inspiring presentation, and really also giving us some insights about the Internet of Things and what it can really do for people, and also that it has to be done by people. Thank you for that. If you could stop sharing your slides, please. Thank you. And I will go back here to my own slides. So we now welcome Jani Mikael Kuusisto, the CEO of Ynvisible. And Jani will give us a talk about Ynvisible, the story of Ynvisible, and how we like to bring things alive. But also Jani will highlight how Ynvisible has been involved with PrintoCent and how PrintoCent has been important as a network to move forward this whole industry of printed electronics. Jani is has almost 20 years of experience in printed electronics. He has held several positions, all connected to business development. And he worked for VTT as well as other companies. He's been involved with Ynvisible since 2011 on and off, and has been the CEO since 2018. So, Jani, over to you. Hello.
Hi, Ines. Hi, everyone. Hope you can hear me okay. If Ines, you
Yes.
stop sharing. We're 1 hour, 5 minutes into this webinar, and always at all these conferences, someone at some point asks you to stand up. I will ask you guys to stand up, but don't leave your computer screen, because before I talk about Ynvisible and our relationship to the PrintoCent community, I want to walk around where I am today. I'm here in Ylöjärvi, Finland, in the facilities of Ysent, or I like to call them Iskent. We at Ynvisible also have that. Is it Y Ynvisible, Invisible? I like to call Ysent, I call it Iskent. I had actually proposed that in this webinar series, Raimo Korhonen would have one of the first talks in this webinar. Many of you may have run into Raimo through the years. He was one of the, or is one of the pioneers in the field of printed intelligence. Ever since the big paper companies in Finland started working with the big electronics companies to look into the future of what can you do with roll-to-roll type processes, what is the future of paper. That was kind of the roots to this entire printed intelligence thing, and Raimo was a critical person, is a critical person in that. However, Raimo is out on business in Germany, so the borders are opening up. Ysent has a nice big order in Germany, so he had to fly on business to deliver the next hot embossing unit. So very happy for him. I know they were anxious for the border to open up. So instead of Raimo, you have to listen to me, and I apologize for that. Finns always like to apologize during their talks, so I'll start with that. Although the previous guys didn't. Anyway, so I'm gonna start walking around a little bit, and I hope you guys are taking the moment to stand up a little if you're tired of sitting and watching for an hour. Why I'm happy to be here. I don't know how you're seeing the screen. I have a split screen, but if you click on me, you can get the full screen mode on what I'm showing you. I wanted to be in their facility for the reason that you get to see what is required to go from a lab scale R&D project, a prototype, to industrial manufacture. Ysent, what they do is they have developed the hot embossing of nanostructures onto different substrates, plastic films, paper. And essentially they can do that by just applying a special tool with special structures with force and heat onto the substrate. And the first step one would do is, from a developmental perspective, have a piece of equipment like this, and then you can run material through it to create holographic type structures, or microfluidics channels, or light guides for solar cells, wide range of applications. So usually things start off small. What happened in 2002 was very fundamental for the birth of PrintoCent as a community. This machine right here, called Pico machine, was developed in collaboration in a publicly funded project, and then there was Metso Corporation and VTT working in unison to introduce this first semi-industrial scale roll-to-roll machine into VTT's facilities in Oulu. And after 17 years of service, that machine has now found its way a little bit south to Tampere region and in the facilities of Ysent. So now this company has the ability to do quick testing on a small one, going into bigger scale, but then beyond pilot, doing it in
Yanni, we are losing your audio. Can you make sure that your microphone is...
Can you hear me?
Yes, now it's fine.
I was moving too fast. I was just getting to how fast these machines run. So maybe I can move so fast. You're okay, hear me?
It's not great. Are you covering the microphone?
No.
Well,
All
but
right.
now better.
Okay. So this kind of machine now runs wide web 300 meters a minute. And I heard that the machine that they're working on in Germany can go up to double speed. And this is not, you know, this is not electronics as you're used to with electronics. This is a whole new world. It's really going back to what Juha said, that curve of all these objects becoming smart. And that's what PrintoCent is all about. That's why they allowed me to be in their facilities. We're working closely with them. And as we are with many other PrintoCent partners. And it's great to see that path and that ability to go from small scale trials to true high volume manufacture. All right. And I'm back. So I'll turn to the slides and the story of Ynvisible. But a shout out to our friends at Ysent, Raimo, Jaakko, good luck out there in Germany. And let me see if I know how to share my slides. Share, here we go. All right, so things alive, why printed intelligence, why PrintoCent, and a little bit of our story. In fact, the best one to tell our story would be Ines. She was one of the founders of this company. And then they happened to find me through different networks while I was working in VTT. But let's tell a little bit about the story of Ynvisible, what we're doing, and how we have benefited from belonging to a partner network like PrintoCent. So our company's starting premises was to bring everyday objects and surfaces to life. The founders of our company saw that intelligence was coming everywhere. This was already 2005, 2006 when the first initiatives were started. Our company was officially founded in 2010 in Lisbon region in Portugal. And the approach to printed electronics, printed intelligence, was perhaps slightly different than for many other companies in our space. It did not start with technology first. It started with a vision, it started with a need, and that need was that people will be surrounded by more and more technologies. And how does a human being more naturally continue living their lives in a world where all the environments and objects are smart without going insane, if you may? And there, the exploration started on looking at different chromogenic systems. Chromogenic means that there is a color change. There are thermochromic systems, which are based on color change in reaction to heat, photochromics in reaction to light. Ynvisible started working with electrochromics. So these are material sets that devices that change the color as a reaction to a redox oxidation process triggered by electricity. And as such, it's very nice for a low power display technology. And especially nice if you take it into a printed world, in a printed form, because most of the displays that we have in our world around us are actually printed graphics. We don't even think of printed graphics as a technology because it is everywhere. You buy a table in IKEA, what looks like wood is not wood, it's a printed graphic. And Ynvisible embarked on bringing those printed graphics to life. And a demonstrator that we still show in practically every single talk. This demonstrator was already down of 2011, 2012. Juha was talking about how some people act smart and maybe are smart, and that similarly objects are becoming smart, and in many ways bear resemblance to humans. Well, here's an example. A soil humidity indicator that easily indicates with a smile or a frown if the soil is dry or if it has humidity. And there the interface is an electrochromic display. And I already mentioned some of the advantages, but certainly the fact that it can be printed, it's ultra low power, you have design freedom in terms of shapes, sizes, you can mold it, you can shape it, you can take it into the structural electronics items. Many, many advantages as a visual, natural interface for these smart objects. And what we have done through the years is we've built the ability to have a full services package. So if and when you want to start working with electrochromics, come to us. You can buy already now, you can buy ink kits from us. If you want to do it everything yourself, if you want to hand produce your first samples, test your own designs, you can buy those inks from us. You can buy display evaluation kits from us, as can be seen here in the bottom left corner. There's the ink kit, and there's one of our evaluation kits. This one is from RDOT. RDOT is a small company originating from Gothenburg, and we bought out their business a couple of weeks back. But also, we have a full services package from design, prototyping, all the way to high volume manufacture. So, had it not been for COVID, I would have been giving this talk either from Portugal or Sweden, one of our production locations, either showing you guys a sheet-based process or a roll-to-roll process. The same capability that Ysent has for these nanostructured surfaces, we have that for electrochromics. In 2018, we went public. We became a Canadian headquartered company. But our operations today are very much so in Portugal. We have design, prototyping, sheet-based production. In Sweden, in Linköping, we have roll-to-roll manufacturing. And in Freiburg, Germany, is where we do our inks developments. So full services package. Of course, I want to pitch our capabilities if there are anyone in the audience that are interested. But I want to come back one step to this slide and partner network, and coming back to PrintoCent and why we have been a member since 2011. And the reason for that is that we cannot do everything by ourselves. This is an emerging sector. There are lots of new material requirements. There are new component designs. There are complementing components to design a full system and a product. And it's great to be a part of this kind of community where we know we can find the complementing skill sets, the complementing capabilities of manufacture and integration. And here's an excellent example. Electrochromics can be used in different wearable items. It's ultra low power, so it's perfectly fit for these types of wearable items. Here's a simple indicator showing you how long you've been in quarantine after your travel. It could be an indicator that shows 20-second hand wash. It's a visual display printed, but it's not just the display. We have to combine it with something else inside. And in the Decochrome, EU-funded Decochrome project, we've been working with many partners, among them VTT, with whom already a couple of years back, we demonstrated a full system on a white PET film. So you had the conductive tracks printed, you had the electrochromic printed, and then through a pick and place process, you assembled all the chips onto it, and then it was overmolded with TPU. Again, capabilities that we as a small company with 30 people in total, if you include the consultants, while we have facilities, we cannot today do all of this by ourselves. And that's why PrintoCent is very important for all its members, both the big companies on the list, as well as the smaller companies on the list. And this is one of the values of being connected. And just to highlight again, all the steps that can go into this manufacture is that, you're printing conductors, you're printing, say, carbon. This example is from our collaboration with Evonik. They have a printed rechargeable battery that can be printed on the same substrates as our displays. And you're starting to share different layers of material. As you see, these are printed, they're mass producible, but to get to the final product, there are many steps and much know-how that needs to be brought together. And I'm happy to say that we have benefited from these collaborations in PrintoCent to be able to reach these levels. We have collaborations beyond PrintoCent, but I do invite those who are here for the first time learning about PrintoCent, do get involved, because here is a network of companies and experts that will make it happen, where the next generation of these products are emerging, better form factors. Here we have a very good client partner in Sweden, Epishine, whose OPV cells are now powering the displays. We eliminate the batteries inside. It's these kind of collaborations that help us improve the products, address those needs that our clients have for our products and solutions. So I've far exceeded my time allocation. Do check us out on social media, get in touch with us, Ynvisible.com. Thanks, everyone.
Thank you, Jenny. It's always great to hear you talk. Okay, everyone, we have heard from our 5 speakers today. I strongly encourage everyone to type in your questions. We will have a Q&A session live in a couple of minutes. Before we go there, I would just like to share my screen again and talk to you briefly about the next sessions of this webinar series. So really do save the date, mark your calendars. There's going to be 2 additional sessions in June and then 3 new ones after the summer holidays in September. The next session on this PrintoCent webinar series on printed intelligence is already June 16th. Okay, so in this session, you're going to be hearing about health and medical everywhere with you. So how we're really starting to see more and more diagnostics, patches, wearables being worn by people everywhere, and really much more user-friendly from that perspective. We have 5 speakers already confirmed for that session, and they will be talking from pilot scale fabrication to automation and mass manufacturing solutions of these different technologies that go into these new devices. So June 16th, Tuesday, To register, you have to go to PrintoCent's website, printocent.net, and do mark your calendars and also spread the word. That would be wonderful. All right, so let's go into our live Q&A session now. We have a couple of questions that I will read and direct to our speakers. I will now stop sharing my screen. So let's go. And the first question we have here is about inkjet printing. And basically the question is inkjet printing a new development in printed intelligence? I'd like Antti from VTT to answer that.
Okay, thank you. It's actually a good question, and I must say that even though not presented today, but the inkjet is a big part in the printed electronics portfolio toolbox, and definitely we also have different materials we need to deposit. We need to deposit sometimes substantially thick layer and solid surfaces. So the transfer from the other printing to digital printing is not so straightforward as it has been seen and graphics, because they are happy with in graphics we are happy with the pixelated structure. So it is part of the future, but not the only way that we can do everything on that.
Thank you, Antti. Okay, next question about 5G and antennas. Can we elaborate more on the application of printed antennas and what this participant is suggesting is that with the arriving of 5G, the size of antennas is becoming smaller. So it seems that the advantage of printed antenna is being lost. Do you want to comment, Juha?
Yes, good question. Can you hear my voice?
Yes, we can hear you.
Good. Yeah, so good question. So yes, especially once we are going on higher frequencies, so the laws of physics just squeeze the wavelength there. So in a nutshell, I would say that the future is kind of hybrid. So there will be needs for different types of antenna solutions. In some cases, they might be kind of hybrid and kind of embedded in structures in ways or another. And then on some cases, we can even print then stuff there. 5G is going to all frequencies. So the 5G will be on these kind of traditional frequencies, like for example 800 megahertz or 600 megahertz, when wavelengths are long, and then on these kind of mid frequencies, 3.5 gigahertz and so on, and then on these higher frequencies. And once we consider about objects, some objects, for example drone, are so crucial that we surely want to have it connected with all possible ways. So it might have a lot of antennas on many frequencies and even on different technologies. So answer is that we need all means of technology to ensure as efficient wireless connectivity as possible.
Very well, thank you very much for your answer. Next question we have is to Ynvisible. This participant is asking about electrochromics and if we use inorganic or organic materials in our devices. I can actually answer that. We use organic materials in our commercial technologies at Ynvisible. We have developments in inorganic materials as well, and intellectual property with electrochromic inorganic materials, but in our current product and technology offerings, we are using organic materials. All right, next question. Someone would like to know more about a smartwatch from Ynvisible and what the battery life is. So I think this is referring to what Yanni showed in his presentation. the smart timer that can be applied to many different situations, applications. Yanni, would you like to say a few words about that?
Yes, so I'm obviously not an electronics designer, not one of our electronics team. I'm just the CEO. But you can use various different power sources inside. Commonly for our prototyping, we just use very simple coin cells to demonstrate the concepts. But when you are able to define the product better, like Eero is doing in the Movesole case, when you actually specify the product, then in many cases we would look to use something else than a coin cell, depending on the use. The ones that I highlighted were uses that were perhaps more shorter term disposable uses. You know, a 14-day quarantine timer. You know, if it's in use for such a time, you want to design the system using components that don't add to electronic waste. And therefore, you would want to look at these printable battery types. The collaboration we announced with Evonik is great for rechargeable, reusable ones. But then I would look at different other battery types like bio batteries that VTT has worked on, Fuelium in Barcelona has been working on. So there are many ways of powering these systems. You can put an OPV cell in combination with Evonik's battery. So I'm not giving you a direct answer, but it's more to do with defining the product and identifying the correct source. I think we are at a maturity level in our industry that there are many exciting powering solutions.
Yes, yes, thank you, Yanni. And of course, you know, the battery solution or the powering solution is always dependent on the type of use that you want for that smart object or device, right? So it's a question that we can't really answer in a straightforward manner without knowing exactly the use. Okay, my dear Finnish friends, there is a question in Finnish that I'm not going to ask from Mikko Mäkinen. Can you read that?
Yeah, I just can answer to Mikko that it's a good idea. We need to discuss this further, that how to utilize printed intelligence for this case, for Wi-Fi amplifier.
All right. All right. And there is a question about a carbon dioxide battery. So let me read it. Are there any future plans to start printing the carbon dioxide battery as a part of the Eco Electronics project? Who would be the right person to answer this? I'm actually not sure exactly.
Yes, definitely. I cannot go. I just don't have the details on the Ecotronics project at the moment. But definitely, the one of the most important aspects of this Ecotronics is the more ecological power sources, because that is many times the big challenge in flexible printed electronics, and definitely we are looking all options to how to get power sources more sustainable in larger extent. We can connect with the more detailed discussion with our printed battery experts for that.
Thank you, Antti. And also still a question on printed batteries. Is there a member of PrintoCent that is focused on the development of printed batteries? Jukka, do you from the company members of PrintoCent, are there now companies that are developing printed batteries?
We do not have a member at the moment, but there is a company which we are cooperating, and they are dealing with the printed batteries, but they are not our members at the moment. But there is existing companies, yes.
Yes, there are existing companies, and Yanni showed one of those companies in his speech. Evonik is a printed battery technology which they are starting to commercialize. So, and it's relatively easy to get that information also from other sources. Okay, then I see we have a few questions that are very specific, for example, about the price of 1,000 pieces of that timer. I think we could take that discussion to a post-webinar. So I encourage you, again, if there are very specific questions you have about the products and technologies of these companies, please fill out the survey and ask those questions there, because then we will take it to a more specific discussion afterwards. All right. One other question that just came up: how much has printed electronics done with rotary screens? So basically rotary screen printing. And who would like to answer that? I can tell you that at Ynvisible, our roll-to-roll production in Linköping is based on rotary screens, and we not only print our own display technology on that equipment, but also a variety of printed electronics technologies, from solar cells to different types of sensors. So I would say that rotary screen is one of the processes that is mostly used in printing these technologies. But if anyone else wants to add to this.
Antti might.
We agree. one of the main tools in printed electronics, definitely.
Yes.
Okay, and another question is about these networks, and if there are other networks in addition to PrintoCent in the world. And the answer is yes, definitely there are other ecosystems. We know a few of them. I don't know if this is something that maybe Yanni or Jukka want to tell us more about.
I mean, I could mention the ones that we're most connected to, in addition to PrintoCent. The Printed Electronics Arena in Norrköping, Sweden is one. The IntelliFlex organization in Canada is definitely one worth noting. Oh, there's actually, now I'm thinking of so many, I don't know which ones all to mention.
In the US.
Antti, what's the name of the one in the US? Netflex?
NextFlex, yeah.
Yes, yes.
And then I would like to mention also the Organic Electronics Association, OEA.
Of course,
of
course. Yes, we're all members in that, yeah.
Yeah. But they're all a little different. The scope is a little bit different, and the model is a little bit different. So
I saw the question was coming from the US, and the Organic Electronics Association is also active in North America as well. So.
Exactly. So lots of organizations to really look into in terms of getting more information about this field. All right, one question that just came up, or two. What methods of keeping the substrate clean prior to the screen printing process are used? Are we using any form of contact cleaning? This is quite specific. Antti, do you want to give a little bit of insight into how we keep the substrate clean? There are several alternatives as far as I know.
Definitely there's several methods, but of course I think the starting point is to have high quality substrate provider. then it seems sometimes that you do, if you don't have any specific process, you do more harm with the money cleaning technologies than any benefit. But it's a complicated and application specific and material specific question.
Yes, absolutely. Okay, one question to Ynvisible. Do we have other colors for electrochromic materials? We get this question in all the webinars we participate in, I think, which says something about the market needs. What are the voltages to induce these phase changes? Yes. I can answer, Yanni can answer. I will say first that we have had one webinar at Ynvisible that has focused on this topic of color change and our partnerships in that field with Georgia Tech and NXN. So please do check our YouTube channel for that webinar if you're interested in this. And the other thing is, yes, different electrochromic materials will have different electrochemical windows in which they are activated, in which the color transition is activated. So the voltage will differ a little bit depending on what electrochromic material you are using. But of course, that's then very specific also to the final solution that you're looking into. Yanni, anything else?
No, I think you answered perfectly. I'll just say that if the question is to give numbers, typically we're in the range between 1 and 3 volts, but also below that as well. Yeah, and do check out on YouTube Ynvisible and the webinar where we talk about color. There's many ways of doing it, but there's one introduced in that webinar.
Yes. One question about if we can provide more insights also into the EU reach of PrintoCent. For example, also with German associations. Will PrintoCent actively reach out with their members to these organizations? And I think this is clearly a question to Jukka.
Yes, hi. So, of course, we are contacting many associations in the EU. We are cooperating with the associations in the EU-funded projects. We know very well the OES. I think they know us as well. And for one example from very near history is that there is an open call between the Business Finland and the same kind of organization in Germany for cooperation project between the Finnish and German companies, and I have shared this information to our members this week and waiting for the answer so that we can collaborate between the PrintoCent and OES members, and that's one example. And of course, we are doing the cooperation and outreaching the other organizations in the EU as well.
Okay, thank you very much for your answer. I think we're really getting to the end of the questions that the participants sent to us. We have a couple of comments here as well, and proposals, but no more active questions. In any way, I remind you that if you do have any other questions that you think about after the webinar session is ended, you can send them through the survey that will be sent right after the session is closed. And even if you don't have more questions to ask to our speakers, we do invite you to fill out the survey so that we have your feedback and any comments, suggestions you might have to improve this webinar series. This is just the first session, so we're really looking into suggestions on how to improve it for the next 5 sessions. There's going to be 6 in total. I remind you about that. And so I think we are now ready to close this this session. Let me just, again, share my screen with you. And to tell you that we're really grateful that you were here today, that you can follow PrintoCent on, and any of the companies that presented here today, on their social media. If you go to PrintoCent's website, you have all the contact information there. Please do download the fantastic handbook on printed intelligence if you want to know more about this set of technologies, and please do register for the next webinar on June 16th on medical health applications of printed electronics and printed intelligence. Again, thank you all. Thank you to the speakers for your participation, for your interesting talks. It was a pleasure to be here, and do keep reaching out to us to tell us more about your needs. Thanks a lot.
Thank you.
Bye-bye, everyone.